Okay, let's take a look at my solution. Well, what I suggest we to try is something like this. If my df, in this case, we are trying to ask Python to evaluate my data frame as a boolean value, and if it is empty, well, it should be a false if it works exactly the same as a list. Well, if you try this, and you will see it doesn't work. And then, I try to do this one. So empty underscore df, that's the data frame name, and then we do a dot empty, and then by doing a dot empty, it will give me either a true or a false. So this is the way that we can check whether a data frame is empty or not. Okay, the next part we want to talk about the slicing. Well, we can slice a sequence, and the syntax will be, the basic version of the syntax will be like this. Well, we do a sum list, or if it is not a list, if it is a tuple, that's okay. If it is string, that's also okay. But most of the case, we want to slice a list. Well, in the syntax, square bracket, and then we specify where to start and where to end. And you want to remember that for the start point, it is included in the slice, but for the endpoint, it is excluded from the slice. Okay, and another thing I want to say is, well, if the start is not specified, and then we are going to start from the index 0 included. So if we don't specify that, we are starting from the very beginning. And for the endpoint, if it's not specified, it will end at the last item, and the last item will also be included. Okay, so let's see if we want to do this one. We want to grab the first four, and for the first four, and they are the index 0, 1, 2, and 3, right? So if we want to create a slice to keep the first four of them, and we don't have to specify where to begin, but we want to end at 4. So 4 is excluded. So we want to start from the very beginning, and then 0, 1, 2, we stop at 3, right? And similarly, if you want to do the last four, and then we can specify where to begin, which is the negative 4. And then, negative 4, negative 3, negative 2, negative 1. So we are keeping the last four of them. Or if we want to do the middle two, and then you can specify the index 3, that's the start point, and then negative 3, that is the end point. Okay, this is the basic version of the slicing. Okay, and if you want to do another way, if you don't want to do a negative 1, and you can also use the length of the sequence. And then here are even more examples. Like, this one is a little bit tricky because we didn't specify where to begin and we didn't specify where to end. So this is a slice, but it seems that we are keeping everything, right? By not specifying where to begin, we are starting from the beginning. By not specifying where to end, we are ending at the last item. So we are just keeping everything. And for this one, we are stopping at the index 5, and for this one, we are stopping at the index negative 1. So we only miss one item. Okay, and then we can say for this one, we are starting at 4, go all the way to the end. We are starting at the third last item and then go all the way to the end. And then we are starting 2 and end at 5, and starting 2 and on the negative 1, which is the last item. So for this one, since we are ending on the last item, negative 1, so we are throwing away the negative 1, which is the last item, right? Okay, so and another thing is, another part I want to explain is when you are doing the slicing, it doesn't matter if it is the basic version of the slicing or later we have an advanced version of the slicing. But for the slicing, we are creating a new list. Okay, this means that if we do a b equals a slicing from 4 to the end, and then, if we want to change the b, we can do that. However, you can have a piece in your mind because for the a is not changed. So when we are making a slice, we are keeping a copy of part of the original list. And then for the A, which is the original list, and then it won't be changed even though we have a slice which is B, and then we change something in the B, it won't have any impact on the A, which is the original copy. Well, and say for this one, we are doing this slicing again. We didn't specify where to begin, we didn't specify where to end, so we are keeping everything. But remember, just now we say when we are doing a slicing, we are making a copy. So this means B is indeed a copy of A. B is a copy of the A, but it has everything of A. What does this mean? This means B is a copy, right? And then if we want to do a comparison, B equals A, and then we are going to have a true saying, yes, they do have the same values. Well, and then if we want to do B is not A, well, this means we are checking if A and B are they referring to same list? So if B is A, and this means even though A and B are two variable names, they are referring to the same item. And then if we are doing B is not A, this means B refers, or B means one list. It is a list in the memory. And then A means another list in the memory. And in the memory, there are two different lists. So by checking B is not A, this shows us B is real copy of A. Okay, well, and then, well, if we want to do something like do some changes, and here is a change we can do using slicing as well. And for example, if we want to change A for the slice 2 to 7, I want to take the slice 2 to 7 out. And then I want to plug in another chunk of the data in, so 99, 20, 22, and 14. So we take some of a slice out, and then we are putting another new slice in. And yes, we can do that. Okay, and this is the basic version of the slicing. And okay, let's come back to the convention of the Python coding. Well, and the next rule we want to talk about is we want to avoid using start, end, and the strand in a single slice. Okay, well, this brings us first to a new version. Well, that is, we can specify where to start, we can specify where to end, and then we can also specify a stride, or we can call that the step size. So for the step size, and this means after we keep one, we can skip the next one or the next end of them, and then we move on to the next. So for example, for this one, so A, and then it's going to be start from the very beginning, it will end at the very end. However, we are specifying the step size to be a 2. By saying the step size is a 2, first we take index 0, and then we increase the index by 2. So next we take the index 2, and then we take the index 4. So every time after we grab one item, we want to increase the index by the value of the stride or the step size. Okay, so for this one, it means that we are doing a take one, skip one, take one, skip one. Or if you want to start from the 1, and then we are starting from the index 1, we take the index 1, and then we skip index 2, we take index 3, and then we want to jump to 5. Okay, so and those are some of the common slicing that we may want to do. And this is also an interesting one. And we don't specify where to begin, we don't specify where to end, but we do a step size as a negative 1. By saying that is a negative 1, so we are reversing the entire list. So it will be a new copy with all the same values, but the entire list reversed. Okay, and then, well, here are some of the other examples. Say we can start from the index 2, and then we go all the way to the end, and then we are doing the step size as a 2. So that is a take one, skip one, take one, skip one. And this one, for the next example, we are using the negative 1, index negative 1 at the start point, and then we go all the way to the end. However, we are using the -2 as a step size. So we are doing the -2, -4, -6, etc. Okay, and here, well, the last one is also a tricky one. So we are saying we want to do the index 2 from index 2 and at index 2, and the step size is a -2. So this will really give you a empty list. Okay, well, I'm showing you those examples because they are really confusing. They are really, really hard to read. Okay, well, in Python, one of the general rule is that we want to avoid using this kind of the slicing. Well, if you have to make a complicated slicing, that you may have to specify or three numbers: the beginning, the end, and the stride or the step size. And then, well, this code will be really hard to understand. Well, one of the way that we can break it and make it a little bit easier will be, well, how about we try to break a big, long, complicated slice into two possible steps of the two smaller steps of the slicing. So for those two steps, and can we do that in one slicing? Well, yes, we can do that, but by separating that into two slices, and it will be easier for us. So for example, the first step, I'm keeping I'm starting from the index 0, and then I take one, skip one, take one, skip one. So this slicing is not so hard to understand. And then after we have the b, and then we are throwing away the first value. We are throwing away the last value, so we are keeping the middle values by throwing the first value and the last value. So for doing this way, well, it will make your code a little bit easier to understand. But anyhow, you really want to avoid those ones. They are the bad examples. Okay? So, well, the next one, we will have an exercise. Well, we are going to try to create a range from 1 to 100, and then we want to make a list like this: 31, and then increase by 3, 34, and increase by 3, 37, etc. We want to stop at 61. So try to use that range and then create a list, and this is the part we have already done, and then try to use proper slicing so that you get this. Well, and even better, remember, we may want to break that to two steps just to make the code a little bit easier to follow. Okay, so go ahead and try this, and well, let's just you should just pause the video because we have already got the end of this lecture. Okay, so go ahead and pause the video, and I will show you my answers in 5 seconds. Okay, well, this is my answer. So for my answer, well, I did the first step by starting at the 20, and then I'm do index 20, and then I'm using the step size as a 3. This is starting at the 30, and then go all the way to the end. I want to take one, skip two, take one, skip two. So then I'm gonna start at the 31, and the step size is also correct, even though I go all the way to 100, no problem. And then I want to fix the right stop point at the second slice. So I'm using two steps of the slicing to get this part done. Well, even though I'm doing one more line of the code, but those two slices will add them together is more acceptable because they look just a little bit better. Okay, well, to sum up, in this lecture, we start to talk more about the concepts in this book. That is, well, our goal is not just to have some working Python code. We want to have our code be Pythonic enough. Well, let me give you a real example. And this one, I'm bringing you a GitHub page, and this is a project called Expertise. Well, this is a project I worked on several years ago, and this project is still alive. And is there a way that I can show you how big it is? Well, anyhow, this project is already more than 10 years old. So this is a really, really old project. And I was once one of the main contributors to this project. And if your company or your team has this kind of code repository, probably not in GitHub, but in a internal, code-based server. And then if you have make some contributions, usually you will have to do a pull request. So for a pull request, this means I have done my part, and then whoever is reviewing my work, go ahead, my work is ready to be reviewed. Okay, and then your reviewer will click on your contribution or your pull request, and then they will go through all the files you have changed. So for this one, I'm going through one of the pull requests, and then I want to scroll down and see, okay, this is a line of the code the contributor takes out, and those 2 lines of the code are what the contributor put in, right? So I want to go through and see the lines one by one, even without running the code. I want to make sure that it just look right. When you make a contribution, you want to make sure, number one, you have the functionality ready, and number two, you have the code style being acceptable. And say for this one, I see some smaller changes, and it seems that they are reasonable. And then I scroll down and I see, okay, this guy is defining one function, another function, and by the way, it is Ruby, not Python, so it looks a little bit different. And I scroll down, okay, even more function definition, and I will see some of the code. If I say, okay, it just look ugly, even though you may have all the correct function, by just eyeballing this code, I say no, this should be rejected because the code is terrible. Okay, and then you don't want to have such a condition. Let's come back to today. We are talking about how to make our code Pythonic enough. The first thing is we talk about the Python version. You want to check the Python version before you start coding. Okay, and then for the coding style, you should follow the coding style provided by your company, your team. Or if your company decide to follow the PEP8 and then PEP8, it is. For the slicing, the general rule is you want to avoid being verbose. And if you specify all 3 numbers, the beginning, the end, and the step size, and this slide just looks so hard to understand. Okay, and if so, you may want to break one complicated slice into 2 or even 3 simpler ones, just to make the code easier to understand. Okay, so that's it for today, and tomorrow we are going to continue showing more of the concepts in this book.